Hello explorers and welcome to another video. Today we are going to talk about LibreChat. And LibreChat is a tool that is very similar to other things that I've looked at on this channel, where you can talk to an LLM pretty much like ChatGPT, Claude, or all of those different providers. But I'm trying to create something that can run locally on my machine as much as possible in order to give me the freedom of having all my data in my own data stores and not giving away that much information to other providers. And this could be very interesting for different companies to set up and so on. And depending on both speed and how much crawling you want to do on the internet, because we have a big problem at the moment. We actually had at work a problem where one of our web services was really heavily crawled by Claude, so we needed to actually just block Claude crawlers from that web service, or else it would have taken down that service. And it's pretty much like a DDoS from these different providers when they are trying to find information on the internet. So of course we need crawlers. We need crawlers like the Googlebot and so on in order to create search indexes and also create metadata and data for different providers. But if everyone starts crawling to feed their LLMs, we will have a big problem because the internet wasn't really made for that. It was made for gathering information or reading information in a leisure time in order to get information that you could use in your work, for instance. And having a search index and then going to a site reading it will not strain the sites as much as if everyone goes and download that site at the same time. We're going to look at a picture here, and that picture is pretty much everything that I'm going to talk about today. So it's a big picture with a lot of different moving parts, but I'm going to go through it in a leisurely time in order to explain every piece of it. Just so you get a picture of what I've set up and of what I've got working at the moment. So this is the picture we're going to talk about, and we have LibreChat here in the middle, and that is the interface where you go, and it's actually a couple of different parts. It has parts for agents, it has an API that you can call in order to do different services, and you also have a web front that you can actually use in order to chat with it. So it's not just one component, it's a multi-component repository, and setting it up is a little bit of a hassle. Developing to it is also a little bit of a hassle, and I have actually written some code for LibreChat in order to get some things to work in this particular case. But what we have here is LibreChat, and we want to chat with it on a different models that is available on the internet. And there is a lot of different open weight models that you can download from the Olama store. So if you have Olama installed on your machine, you can pull different models in order to speak to an LLM pretty much. But it's just an LLM that has that information from when it was built. So the latest model that I have downloaded has some information from January this year. If you want something more recent, it will not have that information. So we have Olama here, we have models, and I have said that these kind of pink boxes here with models, that is something that is required to run on a machine that has GPU in order to get a good performance of that. So in my case, the machine I'm talking to you on now is the one that will run these models on. It's the only one that is powerful enough in order to run Olama. So LibreChat and Olama is set up there. LibreChat has some helping components, the blue ones here. It has a MongoDB where it stores the state. So usually when you have these kind of chats, they remember what you talked about and remember your preferences and also remember what kind of questions you have asked before. And it uses that information in order to give you better results and give you a better experience when you're talking to the LLM. So MongoDB is the storage it uses in order to have that. You also have this Meilisearch engine, and it takes this database and everything that you search for and creates a way for you to find your chats easily. So it's an internal search engine just for finding the particular topic that you were talking about, so you can continue in the same context when you are doing a chat. So it's a very small search engine, and I don't think it has much of I think it might have an SQLite database that it stores information in, or it might just have a search engine that you boots up and start searching in. So it's a standalone executable with some data in there. But when it comes to Olama, if it can't really answer your question with the trained data it already has, it needs to reach out on the web and fetch more information. And that is the step that you usually do online today, because everything is gathered by these large providers. They are gathering so much information about us and everything else on the internet, of course. And that is the challenging part. So what we want to do is we want to talk to Olama, and it realizes that I don't have this information, so it needs to do a web search. And the green boxes here is the flow of that web search. So it's want to do a web search, and you have a model in Olama that has tooling enabled. So some of the models are marked with a tag, says that these can use tools in order to answer your questions. And when it has tool support, it usually have the tool web search as a tool. So I downloaded a model that has web search as a tool. And when I asked Olama and it realized that it can't answer your questions, it will ask LibreChat, do you have a tool called web search? I want to ask you this particular search query. So we get a search query in this web search, and this search query goes to something called SearXNG. So this is a metadata search engine that could just figure out what links are interesting for this particular query. And in the setup here, they have two different search providers. They have Serper and SearXNG. And SearXNG is something that I can host locally. So that is something that I installed. So this is not that complicated. I might make a video that just explains how to set up SearXNG. And as you see here, there is a lot of moving components. So I might do a lot of different videos on different components. But SearXNG stores its data in an SQLite database, and it's just the small metadata about a particular URL and also the URL itself. And it will use cloud providers to search. We don't set up a search engine locally. We could perhaps use this Magnolia search engine that I was talking about in a previous video. But currently you can set it up with a lot of different search engines. You can use Google, you can use DuckDuckGo, and I think the list is like 140 different search engines that you can use in order to gather this metadata information. Currently I've set it up with DuckDuckGo, for instance, so it will go out, fetch some information from DuckDuckGo, and store in its search engine database in this SQLite. Later on, we of course need the actual document that we want to use in order to get the right query answer. And in order to get all the documents from this metadata, we need to use something called Firecrawl. And they also here say that they have scraper providers, Firecrawl and Serper, so they have two different providers there as well. And all of these can be hosted online. So there is a lot of these SearXNG service out there that you can use in order to fetch metadata, and there is a bunch of Firecrawl and Serper installations out there that you can use in order to use a cloud version of this scraper functionality. And when it comes to scraping, as I said before, maybe Firecrawl as a service would be better for the internet, because if everyone starts scraping information, we might have a problem later on. But I ran it locally. It will set up Docker images, a couple of them. So it will run one Docker image with Postgres with a lot of different cron jobs in order to fetch data later on and figure out if that data has changed. So it will do a lot of crawling during its process. It has a Redis service in order to manage when it does the crawling and so on. So it pretty much a job engine used in Redis, and it will use Playwright in order to fetch this data. At least what I understand is that Playwright is using Firefox in order to scrape different sites and so on. So it's also a service that is running in this Firecrawl. So Firecrawl itself is pretty complicated. I haven't looked into it that much, but if in the future you are interested, I will make a video about Firecrawl, and then I will do a deep dive in how that actually works. But then when we have a lot of documents, we have so much information, and we have not only all the documents that we have scraped from the internet, we also have a bunch of documents in our MongoDB, things that we have seen before that might be interesting. So there is a lot of different information that could be interesting to our query. So we need to figure out what is the most significant information that we can use to answer this query. And that's where a re-ranker comes in. And re-ranker there is a couple of different. It's a Gina is one of these services, and Cohere is another service. And both of these services are online services, and I couldn't really find a local version that could do this re-ranking. So I looked at GitHub, found a Python library that could download a couple of different models from Hugging Face, and those models in turn would do a re-ranking. So I just created a new re-ranker, called it Simple Re-rank, and that is what I'm using locally now. So that is the extra code that I needed to add. So I needed to add both to the RAG API in LibreChat, I needed to add my Python code, and then I needed to add a couple of lines of JavaScript code in order to call this new simple version of a re-ranker from LibreChat. So that is some of the code changes I have done. But I got it to work, and it could re-rank documents. Sadly, at the moment, it's very slow when it comes to re-ranking documents. And for some reason, my LibreChat, when it actually does a web search, it tries to web search over and over again. And it fails when it comes to too many iterations. So it does 50 iterations and then fails out. So usually it comes up to like 500 different search queries and scraping and so on before it fails. I'm not sure if it has to do with the context of previous searches, or if it's something else I've done wrong. I haven't looked into that too much. I just got it to work yesterday, so I need some more time to figure this out and get a good working system. But after this re-ranker, we have documents, result documents, in order of significance that we could use in order to answer our query. So these result documents will then be fed back into Olama and say, okay, here is your result for this web query. Now you can answer the question, and Olama summarize the documents and figure out how could I, in the best way, create a bunch of words, randomly generate a bunch of words from this document in order to satisfy the user in LibreChat. So this is pretty much how the system works. It's a lot of different components, and if you set it up locally, of course you need to do a bunch of work and most of these different services might need their own machine. And we can also see that both Olama needs models that are running on the GPU, and we also need models for the Reranker, so that needs to be running on a machine with a GPU. I know that Firecrawl is using a lot of CPU and memory. You can even tell it to say, I want you to use 80% of the memory and 80% of the CPU on this machine, and it will definitely use that. Currently, because I'm running out on a machine that are doing a lot of different work, I've set it to 50%, and it takes up all of it in order to do this as quickly as possible. SearXNG doesn't really need that much power, and it's very quick because it's mostly just doing search query and storing information, so it's not that heavy. But most of these services could have their own machine, and also these services that are complementary, like MongoDBs and Postgres and so on. The Postgres here should actually have been blue, right? So this is the way it should have looked. So all of these helping services could of course be running on their own machines as well. So there is a lot in this cluster in order to get a LibreChat to work. This was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you want to support the channel, there is the donation links and affiliate links in the description. If you have any comments or suggestions, leave those in the comment section down below, and I really hope to see you in the next video.